Alrighty. Good morning, everybody. We are going to get started now. Welcome to the second webinar in our monthly webinar series on advanced air mobility. My name is Jackson Piper. I am a program coordinator with AirTap at the Center for Transportation Studies at the University of Minnesota. I'm sure many of you on the call here today on the webinar have attended webinar number 1 and have attended another AirTap webinar. For those of you who have not, I'm just going to briefly provide a little information about what AirTap is and what we do. So first of all, this workshop series is sponsored by MnDOT's Office of Aeronautics and is administered by the Airport Technical Assistance Program, that's us, AirTap, at the Center for Transportation Studies at the University of Minnesota. AirTap collaborates with MnDOT Aeronautics and the Minnesota Council of Airports to provide education, training, and expertise to the aviation community. AirTap is a program that offers practical yet specialized training and resources across the state for those who operate, maintain, and administer Minnesota's public use airports. Minnesota's general aviation personnel across the state have had access to targeted information and training to reduce costs and improve the safety, quality, and overall efficiency of airport operations. AirTap provides 4 major service categories. The first is education and training, also technical assistance, access to experts, and resources and printed materials. Again, this is the second webinar in this series. Last month's session was recorded and is now available on our website. This webinar and all the others in the series that follow will be recorded and available on our website as well, airtap.umn.edu. Just some housekeeping for today. Video and audio for all participants is turned off, but you can communicate with the speaker or with other participants by using the chat and QA boxes at the bottom of your screen. You can use the chat feature to introduce yourself or to share ideas with the rest of the participants, or to let us, the panelists, know that you need technical assistance. You can use the Q&A feature in the middle. If you have a question for the speaker, I will be monitoring the Q&A throughout the webinar. So again, if you have a question that you want to share, just plug it in. So in addition to Joseph Block from MnDOT, we are excited to welcome a special guest speaker, Laura Morejon Ramirez from Whisper Aero. And I'll just give a quick introduction to Laura. She is, again, Whisper Aero's project engineer with research experience in electric aviation and regional air mobility. She's worked as a grad research assistant at the Aerospace Systems Design Laboratory at Georgia Tech, where she performed NASA-funded academic research exploring the feasibility of sustainable regional air mobility using next-generation electric and hybrid electric aircraft. Laura has had a flight test internship and a mechanical engineering internship at Project Loon. She graduated from the University of California, San Diego with a BS in aerospace engineering in 2020, and from Georgia Tech with an MS in aerospace engineering in 2022. So Laura, welcome. I am going to hand it off now.
Thank you, Jackson, and thank you, Joseph, and everyone who's here today. I'm very excited. Let me share my screen real quick. All right, hopefully everyone can hear me, see me okay, and see my slides as well. If it looks like I'm not switching slides, let me know and I'll fix it. As Jackson said, my name is Laura. I work for Whisper Aero. We are a Tennessee-based aerospace engineering company, about 3.5 years old. And I'm here today to talk about the electrification of flight. And under the assumption that most of my audience will be from Minnesota, we'll have a little bit of a focus on Minnesota, but generally talk about regional air mobility, the future of electric flight, and how to achieve economically viable mobility of people and things. So a little bit about our company. We were funded in 2020, so about 3.5 years old. So far, we've raised $51 million in VC, and we have grown to 3 offices. We have about 50 employees now and 56,000 square feet, everything in Tennessee. A fun fact about our company is that we were funded in a small, well, rather big, I guess, plot of land that our CEO, Mark Moore, purchased in 2020. And that the picture to the left is where we all worked, lived, and tested our technology. If you actually look in the top left corner of that picture, that is the municipal airport at our home base of Crossville. And to the right, we had a lake. So it was a perfect setting for quietly, pun intended, developing our tech when we were still in stealth mode and then testing it in the airport right next door. And actually that same airport is where just a few months ago, we opened to the public our flight test center that the state of Tennessee graciously donated to us to continue the testing of our technology. In the bottom, you can see just some of the state partnerships that we've forged over the years with our home state. Definitely not an exhaustive list, but interestingly, since today we're talking with through the Department of Transportation in Minnesota, I would like to give a shout out to the Department of Transportation in Tennessee, who we have a great relationship with, and the whole state really has been very welcoming to a very, advanced next generation electric engineering company for kind of setting roots in this state of Tennessee that we love so much. So what is it exactly that we do? Even though you saw an aircraft in the first slide, we're not another aircraft company. We're actually more closely related to an engine company. Although our engines are electric, we call them electric ducted fans, and I'll break that down. The ducted part is the easiest one to understand. Instead of an open propeller that you might see in a helicopter, a small drone, or even larger aircraft, our engines are protected by a duct, and the inside is quite simple. There's one rotating part that we call a blisk, a bladed disc. That's where a lot of our IP and kind of the secret sauce that makes our tech lives. Then there's a motor driving that, and then there's a stator face that's not moving. And the important thing about electric ducted fans is that they often, and until today, have caused a lot of efficiency losses, as well as noise sources from something that we call the tip gap, the gap between where the blade ends and where the duct begins. And at Whisper, we've actually found a way to not only reduce, but completely eliminate that tip gap, which has led to an increase in efficiency and a decrease in noise, hence our name. We were founded upon the idea that the key to scale at all levels of movement of things, cargo, passengers, or even smaller packages, is noise. And I'll dive into that a little bit more, but we basically started this company upon the foundation or the idea that unless you make the act of moving air really quiet, you won't be able to move a lot of things and people in a way that's economical and societally acceptable. So we've developed a technology that not only is quieter and efficient and more efficient than anything else out there, it also is scalable. So when you think about the advanced air mobility term that we kind of all have become pretty aware of in the last, I would say, 10 years or so, and more so every day, there's 3 buckets that I like to think about. And they all have a place in the advanced air mobility umbrella, but they all have different missions and different objectives that they meet. On one hand, at the lower end, you can think of drones. At this point, drones are a pretty ubiquitous thing. You can go to a Best Buy and purchase a photography drone to go around during a trip and take pictures of beautiful landscapes. But you also see in some specific markets in the US and even internationally, the concept of drone delivery becoming more ubiquitous and available. And that's with, small vehicles that can carry a few pounds of cargo to right to your front yard, right? Or on the socially kind of beneficiary side of things, you can think of organ transports and blood transports between hospitals. Drone delivery has a lot of potential for within the next few years become a really fast way for moving things that have really high value that we need right away. And there's a lot of companies working to develop these drones. Most of those drones, if you're familiar with the space, if not, you can Google some of those companies that I wrote down, tend to have open propellers. The one you see here is one example. And as I was talking about the ducted fan versus open propeller, one major issue that these drones have, and I'm sure some of you might have experienced this personally, is the noise they generate. You need a lot of open props spinning pretty fast, making a lot of noise to make something fly vertically. At the larger scale, we have air taxis. Again, this is something that just 10, 15 years ago, we probably all would have said, oh, that's so far into the future. There's no way I'll be alive by the time one of those flies. And today we have lots of companies. Again, this list is non-exhaustive, but so many different companies in the US, in Europe, and many other countries developing air taxis, aircraft that have a cabin the size of around a car, can sit perhaps 4 passengers and 1 pilot, or eventually even no pilots, right? And can take off vertically and land vertically, but they can transition to forward flight. The concept of operations we often refer to as urban air mobility. And again, this is a subsection of the bigger advanced air mobility market. And we see, players like Archer, Joby, Whisk, kind of developing these aircraft, again, with multiple open propellers that eventually will operate out of, for example, heliports on top of large buildings, or a heliport in a small airport, and be able to carry between 2 and 4 people from place to place. The distances that these aircraft will be able to travel are very much dependent on the state of battery technology. There's a very important term called specific energy, and that's how much battery energy you can fit into a unit of weight. For fuel, the thing that we often use for helicopters, normal conventional aircraft, the specific energy is really, really high. So for a given aircraft weight, you can go a lot farther if it has fuel than it has electricity. Now, all these air taxis are fully electric, and that mixed with the fact that they have to spend a lot of their energy taking off and landing, constrains their range quite a bit. So we see, future urban air mobility routes ranging in range between, say, 10 miles and 50 miles. You can think of it as short hops within one city, at most from a suburb of a city into the city for, a stadium concert or something like that, or a sports game, or the Olympics, or I'm sure you guys have heard of many of these use cases. But again, the range capabilities of these aircraft will be quite limited, just given their physical properties. At the higher end, we have just conventional looking aircraft that are electrified, most of the time hybrid electric, and they don't take off vertically, they take off conventionally. So we call them conventional takeoff and landing aircraft. And on the outside, they might look pretty similar to what we're more used to, but because they are electric, they actually have a lot of positive impact in terms of the economics, and they have a lot of potential in terms of range, thanks to that, again, hybrid powertrain. Same as with urban air mobility, this is a side of advanced air mobility that just a couple of decades ago was felt very far off. But because of the more pragmatic approach that these players, OEMs are taking, there's actually a chance that these airplanes, even though they're bigger, might make it to market and succeed and do so in an economically viable way, even faster or at the same time as air taxis. So I want to now address the blue mark that goes across my slide. At Whisper Aero, we identify as a propulsion provider. What we develop are not full-scale aircraft, but the propulsion systems that would go in the aircraft of the future. As you saw before, we have developed an electric ducted fan that is actually its benefits range from really small scale, even smaller than the drone scale that you see here, all the way up to the large aircraft. And so the common property that you can see across these three aircraft that I've shown here is that they all utilize open propellers. And open propellers, I mean, I'm sure everyone's familiar with the noise that a helicopter makes. When you distribute that into more smaller open propellers, there's some benefits to the noise to that as well as the safety. But there's still a pretty high level of noise that these open props are going to make. There's also a big impact in efficiency that Whisper Aero's electric ducted fans can tackle. But it is the noise that will allow us eventually, when we're able to lower it, to make all of these activities, you know, from drone delivery to air taxis in cities to regional air mobility in the farther away regions. Once we bring those noise levels down, we will be able to make these accessible and affordable to all. So an interesting thing about regional air mobility is that where urban air mobility is seen as a new concept that is perhaps replacing trips taken today by taxi, by ground transportation, or perhaps a very small amount by helicopters, regional air mobility to an extent already exists today. This map that you see here is from 2019, the routes, the air routes that took place across the US between 50 and 500 miles in length, more than once a week. So these are the routes that, you know, in California, you might see San Diego to Los Angeles, or LA to San Francisco, or in Minnesota, you can see many routes departing from Minneapolis. But all of these are less than 500 miles in length. These, until today, are operated by, you know, conventional aircraft, often small ones. You can see the color coding shows you the size of the aircraft that took these routes, anywhere from 6 to 9 seats aboard, say, a Pilatus PC-12 or a Tecnam or a Cessna Grand Caravan. If you've traveled in Hawaii between the islands there, or in the Northeast, or even within Minnesota, you might have boarded one of these aircraft yourself. And going bigger and bigger, we have aircraft between 20 and 50 seats, and then aircraft bigger than 51 seats. These might be your Boeings and Airbuses that take you on a little longer routes, and routes that have a lot of demand. So importantly, this map shows the heavily hub and spoke system that we follow in the US, where we aggregate demand into one major hub, and then we disaggregate or distribute that demand into wherever those passengers want to go. While there's a lot of lines here, there's a lot of routes, there's also a lot of blanks in the map. And that makes you wonder, is there just simply no demand there? Or is it perhaps that we haven't found a way to economically operate these routes? And I'll just zoom in again, because I want to cater to my audience, to Minnesota, and show just how many routes we have within the state of Minnesota that are, again, well within 500 miles, and that many people probably in this call have taken to go visit family, or go for a work trip for a day or two. Now, Minnesota, just like Tennessee, is actually a really good incubator state for regional air mobility. Every blue dot that you see in the left in the map here is an airport, and you actually might live a lot closer to an airport than you might imagine. As I mentioned, we ourselves in Crossville started the company a 2-minute drive away from the Crossville Municipal Airport. Every county in Minnesota has more than one airport, probably 2 on average, for a total of 133. These are just the public use airports. There's a lot of private use airports that we don't even need to talk about, because there's plenty of public use airports that are, you know, being kept in good shape by taxpayer dollars, that have plenty long runways to operate out of, but that until today we've only thought of as general aviation airports. Those are, you know, for use by people that have pilot's licenses or private jets and lots of money to travel, you know, privately. The state of Minnesota has 5.7 million in population. Again, similar to Tennessee, we have 7 million people. And there's only 5 metropolitan areas, which actually are pretty well represented by the squares in the map. Those are the Part 139 airports. These are the airports that are a little bit better equipped to operate a lot of flights every day, potentially have a control tower. They have TSA and programs in place to have a large traffic of people going through every day. But with 5 metro areas, Minnesota actually has 66 mostly rural counties. So counties where, the population is pretty low, the density of population, and you can see that on the left with the color coding of the counties. Again, you guys probably know a lot more about your state than I do, but I did the same research for Tennessee, and it's funny to draw those similarities. And it's just interesting how the US is actually made up of a lot of states like this, where you do have 2, 3, 4, 5 big cities, but other than that, you have a lot of rather sparsely populated counties where, people don't often travel to because there's no way to travel to other than by car. A really important note is that Minnesota is home to 14 subsidized essential air service routes. I believe Joseph may have covered this last week in the first webinar, but I want to touch on it a little bit because it's a very interesting concept that we can definitely leverage in the future of regional air mobility. Essential Air Services is a program that has been in place for 40 years, wherein the Department of Transportation of the US subsidizes for operators. Think of SkyWest or WestJet or Cape Air, Makulele. These small airlines get subsidies so that they can affordably for them operate these routes that otherwise passengers would not be able to afford, so that they can charge normal ticket prices. The reason this program was put in place is that the airplanes that have been used until then to operate these routes are actually really expensive to operate, especially in the short routes. But it's a really good, well-meaning program in that it allows for people to be able to travel, again, routes up to 500 miles or even longer that they might not be able to do by car in a way, that is time efficient. Although today I won't be focusing too much on the cargo, I did want to point out that there's 7 cargo feeder airlines in Minnesota alone. So while regional air mobility, the first focus is on passenger movement, there's a really important synergy as well with cargo. And if you think of your highways in your state, I certainly have have crossed a lot of trucks in highways in Tennessee that are moving truckloads of cargo in between distances that are pretty short. There's definitely an opportunity there to move some of that cargo transport up to the sky and perhaps free our highways a little bit. So that's just another interesting idea for regional air mobility. And I touched a little bit on the economics of regional aircraft today, and I want to dive a little bit deeper into that. A year ago, our company did some research into just what I was just talking about, Essential Air Service Program. Because it's a government subsidized program, there's a lot of data available on the where these dollars are going. And we took 2 of the many airlines that are subsidized by Essential Air Services and figured out just how much the dollar amount was for every mile and passenger traveled. So on the y-axis here, you can see the normalized dollar per passenger mile for in 2023 dollars. And on the x-axis, you can see trip length. So for a 100-mile trip, for example, you can see that Cape Air it costs a little bit under $1.50 to operate. For a 200-mile trip, it goes down a little bit. Now, if you see the shape of these curves, it's very obvious that at the lower mission ranges, basically the trip lengths, the dollar amount increases. This is because of things like fuel and engine maintenance that are costs that you cannot amortize effectively, even at the shorter amounts. So if you think of the shortest trip you've ever taken, for example, again, just back to the Hawaii example, a quick island hop, It might be a 30, 40, 50-mile trip, but you might still notice that the aircraft is trying to climb to get to cruise altitude, only to come right back down to descend because they've gotten to their destination. Internal combustion engines and aircraft equipped with them function best and are most fuel efficient at really high altitudes. When you've traveled in really big airliners, you might be going all the way up to 60,000 feet of altitude. This works really well in really long trips because you have plenty of time to climb, and then you stay for most of the trip in cruise where you're most fuel efficient. But for really short trips, this really hurts the aircraft and therefore the airline. So one of the main cost driver for today's conventional airplanes is fuel. And again, that's most seen in the shorter routes. Another important thing with regional airlines is low utilization. There's a lot of fixed costs that are just being wasted while a plane is being parked on a tarmac instead of flying. You really want to increase efficiency and how many hours you're flying your aircraft, again, from the airline perspective, so that you can reduce those fixed costs. And then finally, there's low load factors. Even though these airplanes are rather small, Cape Air operates six-seat aircraft. Mokulele, similar, 6 to 9. They actually sometimes don't get filled all the way, but they still fly, right? So even though one ticket might cost $100 to a passenger, the airline is paying a lot more to have those empty seats. So there's definitely a mismatch between number of seats and seats filled that is hurting and making these prices go up. Some airlines not under subsidies like the Essential Air Services are figuring out ways to bring those costs down. One of the many is JSX. I don't believe they operate out of Minnesota or Nashville or Tennessee, although they used to. But basically what they do is operate at a bit of a higher price point for the passenger, larger aircraft that do fly a lot more often. So even though these costs look lower, it's because, or the reason they look lower is that even though they are using conventional aircraft, they are larger aircraft that they are more successful in filling. So this kind of shows that there's definitely a way to get down to better cost targets. However, an interesting point in this graph is that you'll see the JSX line starts at around 190 miles. There's nothing before that. And that's because JSX does not, at least at the time of the making of this graph, does not fly routes any shorter than 180 miles. That begs the question, how high would that graph go if they were to fly a 100-mile trip? So even though they've figured out, JSX and others with conventional aircraft today, how to drive costs down, there's definitely opportunity to bring those costs down even more. And that's where the regional air mobility, or RAM, opportunity space lives. There's the standard driving rate provided by the IRS every year that is basically a cost per passenger mile for work travel. There's also the concept of time, the value of time for a specific person, and just how much you're willing to pay to travel a specific distance and basically spend a specific time traveling. All of that needs to be taken into account when we model the cost of future regional air mobility aircraft. If we're able to bring costs down to this blue rectangle under around 60 cents per passenger mile, we will be able to do a lot more flights aboard these electrified aircraft. So on the right here, I have some of the needs for an economically viable transportation system. I don't love the word affordable because, again, same as with value of time, there's a lot of subjectivity to that. But economically viability just means the business running this operation, meaning the airline, even the airports, are profitable, and the passengers are able to afford those prices for a very synergistic program in which people are getting to the places they want faster, and these airlines don't need, for example, subsidies for the government. So on one hand, we have reliable energy. Today, all of our aircraft use aviation fuel, so a fuel of some sort. We're also exploring sustainable aviation fuels, but there's also the idea of electricity. And it's like, if we move towards a more electric aviation system, we must make sure that we have a reliable way to access that energy. We also need to figure out available infrastructure. For the urban air mobility case, I mentioned, the need for heliports that might already exist, but also the building of new heliports. With regional air mobility, there's definitely an opportunity to leverage existing airports, like the 133 public use airports in Minnesota that I mentioned earlier. We also need existing demand. Like I showed in my map of the US, and then the zooming in to Minnesota, there's definitely already evidence of existing demand. If there was no demand in these routes, those airlines would not be flying them. Again, back to the profitability case. So there's a lot of data to be used for these future RAM operators. And we can start as easy as, looking at the routes that are being flown today. And eventually, when the aircraft of the future are available, retiring the current fleet and substituting it with a new fleet of electrified, more affordable aircraft. And then finally, we have a really important one, community acceptance. We talk a lot about, reamping existing airports and making them usable by more people in the community. But what does that bring to the community? And is the community able to accept this new, flow of traffic and potential noise? So back to the concept of noise as the barrier to scale. At Whisper, we firmly believe that unless we make these advanced aircraft concepts extremely quiet and their noise be able to blend into the atmosphere, those future operations, while beta operations might be possible, and in fact are possible today, the scalability of those operations is going to be met with a lot of resistance from the communities unless those noise issues are addressed early on. So again, with drone delivery, that's a great example, because while there's a lot of interesting data being collected today by many companies that are flying, with packages right to your backyard, these are very specific use cases in just a few cities in the US. There's definitely a lot of complaints about noise, and it's just interesting to think about how can we make the future, the drones that will replace the ones that are operating today a lot quieter, so we can truly achieve scale. So this is obvious by now, but at Whisper, we believe that the future of aviation is electric, quiet, and affordable from the passenger perspective, economically viable from just the high level. So what we see here is a render of what the future of aviation might look like. We keep going back to that concept of, smaller airports being revamped for operations. Regional operations, you can think of a trip you might have to take for work. I mean, I myself travel within Tennessee a lot to do different conferences and things like that. And sometimes I find myself driving, 2, 3, 4 hours a day, just without even leaving my state. And I definitely wish there was an option that felt like a private jet, but didn't have that price tag. And regional air mobility is the promise of just that. With a small aircraft of no more than 9 seats, you're able to fill those seats easier instead of having to fly a really large aircraft that then you are flying, half empty. And also with 9 passengers, you're able to fly those aircraft with only 1 pilot. There's a lot of different regulations at different passenger capacities, and keeping your airplane small at 9 passengers, but as safe as those large ones, allows you to fly with 1 pilot to, again, lower those labor costs that I was mentioning earlier. While urban air mobility aircraft are coming online that have vertical takeoff and landing capabilities, there's actually a point to be made about, just making normal conventional takeoff and landing aircraft that just have a takeoff field length of less than 3,000 feet. Out of the 5,000 airports in the US, over 80% of them have more than 3,000 feet of length in their runways. So basically, you could virtually operate out of most public use airports in the US without having a need for even short takeoff and landing capabilities. A really important one is fast cruise speed. 250 knots is the cutoff after which you can't go faster than that under a certain altitude. So going just right there against the limit allows you to make your trips faster, get to your destination faster, so that you can quick change your aircraft and quickly go around and go to the next destination with passengers again. This really matters for that utilization factor that I was telling you about, that airlines essentially divide all their costs among. So basically, if you fly 1,000 hours versus 2,000 hours, you're going to be a lot more profitable. And then finally, the range is important. I showed that map of the US, and there's definitely a point to be made about the amount of routes that already exist today and are being flown within the US that are less than 500 miles in range. And with the state of battery energy density and specific energy today, 500 miles is actually the most a very pragmatic and conservative approach. You can definitely get, with today's battery and technology, and with the help of hybrid systems with a turbo generator that you can turn on to extend your range, 500 miles is totally achievable. In a research paper that we published last year about the Whisper jet, which you see here, that's our concept aircraft that we again don't plan on building, but we believe is the best integration of our technology into a full-scale aircraft. We mentioned that the full electric range of the aircraft would be around 160 miles, after which, again, you become hybrid. So what that means is that you don't have to turn on your turbo generator at all, but you do have it there for longer trips than 160 miles. And because the price of electricity is a lot lower than the price of fuel, even though charging infrastructure, et cetera, has to be put in place, the actual electricity will cost airlines just a fraction of what the fuel they're using today costs them. So energy cost, another big cost driver for airlines today, will be majorly lowered, especially at those low ranges that we were talking are so painful for airlines today, where they're paying up to $3 per passenger mile. So we've mentioned airports a lot, and I know this webinar series kind of focuses on very realistic approaches to how we can get to this. How do we make this possible? And infrastructure is a huge one. There's definitely lots of conversation happening. It's very exciting because we are finally kind of, I think, as a nation, kind of understanding, okay, we have a lot of airports and we have this potential for revitalizing them, and not only revitalizing them, but actually converting them into hubs that impact the residents of that city, but also the economic and energy status. So again, this is a render that kind of shows you just how much we could do with our airports today to make them become mobility, energy, commerce, and tourism hubs. There's lots of counties, cities, municipalities in Minnesota, in Tennessee, all across the US that might feel a bit more forgotten today because they're harder to get to. You would have to drive there to get there. Making those small airports in those small towns hubs of mobility would actually bring a lot of economic growth to these towns and would allow for states and regions to be much more connected. On the cargo side, which you see here on the left, the airports themselves can have a distribution center where the same way that big airports do today, if you go to BNA in Nashville or Minneapolis in Minnesota, you'll find that right next to the airport, there's a large distribution center. There's big, FedEx and UPS planes landing with all their cargo. And from there, everything is distributed into trucks to get to their final destination. What if we could use these smaller airports to do that last mile or second to last mile, and then with small cars and small trucks, you can distribute your freight within that town. That not only would help people get their packages better, earn faster, but also, again, that town bring more jobs and more economic growth. There's also potential for energy not only energy, but sustainable energy production at these airports. That might look different from region to region, but in Tennessee and Minnesota, solar panels might be a really good solution. There's in fact a lot of rules around land use around airports, where you have to have a specific amount of space around the runway with no buildings on them, but there's actually potential for that land to be covered in solar panels. Or you can, think of other ways of producing sustainable energy, and that energy can produce right there in the state, can be directly used to charge these aircraft and all the other electric infrastructure at the airport. And there's also a potential for a buyback program through which the town or municipality is generating more energy and then taking some of that electricity for use by its residents. So there's a really good synergy there where the airport, which again, we might live really close to, but not have ever touched in our lives, might become a really important place for people to get together, to travel to other places, etc. So with that in mind, last year at Whisper, we actually launched the coalition called Reconnecting. It's kind of a play on words where it's reconnect. Let's connect our region again, but also regionally connect. And then obviously Tennessee, this is kind of how we started in our state. But after doing a little bit more research into Minnesota and, in general, the Midwest and all of these regions where perhaps there's not huge density of population, I am confident that similar coalitions could come online that would help all these different states bring regional air mobility to their people. And the way we created it is we divided the coalition into 5 different verticals or 5 different foci. On one hand, you have aviation innovations. That's kind of what Whisper falls under. It's the idea that we should develop cutting edge technology to be put into our aircraft. Some of the airplanes we're flying in today are over 50 years old. So whenever the next generation comes, what is the type of technology that we want to see there? Then we have existing airports. I've talked a lot about that and feel very passionate about that. In Tennessee, we have 76 public airports. So actually, Minnesota, you guys have just over twice as much. And leveraging these airports and making sure they are basically infrastructurally ready to take on these new operations is really important. This would lead to more mobility. So how do we get people to move more within their state, do the trips they have to do, but also how do you make more demand, induce more demand where before people might not have been moved to take that trip just because the barrier to entry is too high. Energy resilience is really important. I've talked about that. It's really important that we make sure that if all of these electric aircraft come online, we have available infrastructure to charge them and that our grid is able to take on that added demand. And then finally, economic growth. There's lots of different ways that our economy can and will be exercised by this kind of new era of mobility. And it's an exciting time to create more jobs in rural areas, in urban areas, and basically bring together the states. In Tennessee, there's a problem with retention with our schools where people might study here but might move away to work someplace else, and we're very passionate about keeping those jobs here, and I'm sure in Minnesota as well. So even though this one is called Reconnecting, I'm confident that we can perhaps begin Reconnect Min, where in the future we might put together a lot of local Minnesota companies and government institutions as well as academic institutions to work together to bring regional air mobility and advanced air mobility to your state. And with that, that ends my presentation. I think we have 13 minutes, so I would love to address your questions. I'll stop sharing. Thank you all.
Thanks, Laura. One thing I'll just jump in with quick as a quick follow-up to everything that you just shared, which, by the way, one idea that I had as you were sharing Reconnecting is Minnesotan, TN at the end there, right? Anyways, I think some folks can probably create some pretty creative branding for what that could look like here in Minnesota. A shameless plug, though. is, and I talked about this last time on the first webinar, our Minnesota Electric Aviation Network study that we are gearing up for. Can't say as much about it now because the RFP is open, but just would encourage folks to take a look at that. It's really an exciting phase that I think we're gearing up for here. And again, the intent there is let's leverage our existing airports. Let's look where it makes sense to electrify today, both from the supply and demand side. And then let's start making a plan on how we're going to get there, right? To support great companies like Whisper and others that are looking to electrify aviation in a lot of ways. So with that being said, I don't know if we've received any questions so far in the Q&A. If you have any questions, feel free to drop those in.
Oh, I see one. Thank you, Boomin. Thanks for your question. It says, has Whisper Aero considered or looked into what electric or hybrid propulsion information pilots will need to fly these novel aircraft? Yes, that's a great question. So basically training for our pilots might look different in 10, 20 years. It actually already looks different today. There's actually training aircraft are a really good use case because pilots that are learning to fly do so in like pretty short distances. So there's already companies developing electric aircraft for pilot training purposes. And that's a really good place to start because if you train on an electric aircraft, you'll easily transfer your skills onto another electric aircraft for your job. But I definitely think that the barrier to entry for electric flight will be lower. I myself just became a pilot 2 months ago. Just for fun. I fly, a Cessna 172 that was made before my mother was born. So it's kind of quite the opposite. I'm in love with, the old school feel of it, but I'm also so excited to eventually learn how to fly an electric aircraft. During my flight test internship at Joby, I got to see the plane every day. I mean, we were flight testing it, but also I got to use the simulator that the company has developed to, again, eventually train their future pilots. And it was so much easier to fly than what I now know is to fly a conventional aircraft. So I think the training will be different, but I don't necessarily think it will be harder. One important thing will be, dealing with battery state is just a thing we'll have to adapt to, where fuel just depletes in a linear way. Battery depletes like slowly and then really fast. You probably know that with your phone, you're at 20% and then it dies an hour later and you're like, whoa. So that there's definitely a lot of, safety precautions that we have to develop with the FAA, as well as just training so that the pilot knows exactly how much range they have left. But I definitely think that the industry is moving in that direction, and we're answering all those questions as we go.
Laura, maybe a quick plug there as well would be the Gamma white paper on I forget exactly what it's called, but they talk to managing range and endurance for electric aviation, I think is what it's called, right? But they talk about a lot of those unique characteristics of managing your battery and your energy and your power in electric aviation, and they talk to that steady decline in voltage as you draw down that battery. So a plug there, I guess.
Yeah, and I guess the last thing I'll say is we've seen this in cars as well, where, electric cars were very rare and like not that good in terms of range just 10 years ago. I remember driving my mom Nissan Leaf and like barely getting home with battery left. And, now people that own electric cars are a lot better at understanding how their battery is being managed and how to manage it. So I think it's just going to become a more ubiquitous thing where everyone's just thinking about electricity because everything we use has it. All right, Tom asked, can you speak to the practicality and of electrified air transport in Minnesota's climate, especially the harsh winters of northern Minnesota? I assume the revenue per available mile is reduced during the winter months. Yeah, so I think that's like a twofold thing. There's the demand side, how much do people really want to travel during those times versus like huddle up at home. And then there's also the technical side. How do electric motors function in cold weather? Versus engines? One good thing is electric motors do better in cold weather than an engine. Tennessee winter has nothing to do with what you guys deal with, but in the winter, to cold start an engine can take you like 10 minutes, a small, Cessna engine. So I think at the very least, problems like that will be resolved or at least minimized. But definitely on, runway icing and things like that, aircraft icing. I mean, airplanes today already have a lot of de-icing solutions in them. The technology there is only going to get better. But in terms of the demand, the shape of the demand will likely stay the same, and operators will just have to optimize for addressing that demand without losing out on the economic side of it. But great question. And I think, as I said, just to keep going on that, I guess, as I mentioned, the solar panels solution, like that's something that would for sure work in Tennessee, for example, somewhere in Texas, like Texas as well. But there's definitely a state by state solution that would work somewhere and what might not in others. So whatever sustainable energy production way works best in Minnesota, I'm sure could be a good solution as well.
Yeah, and Laura, I'll just add on to that as well, that from everything I've heard, again, this is maybe just echoing your point that colder weather actually is better for battery electric.
Yeah.
And, I imagine that most folks that are putting in the capital for a newer, let's say, electric aircraft are probably going to utilize heated hangar storage and or just generally speaking hangars where, you're not going to have to deal with some of the complexities of storing your aircraft on the ramp and having to do all the cold start procedures like you're talking about. So,
Yeah.
But great question, Tom.
Oops. One last thing I'll say, because I don't think I had this on my slide deck, but if anyone's interested in knowing more about Whisper, our website is really easy, whisper.aero, and we are we update the most on LinkedIn, so feel free to follow us on LinkedIn, again, whisper.aero. I think a question just came in. When do you expect your propulsion engine to be certified and ready for the industry? From Sven. Thanks for the question. So we are right now, if you're familiar with TRL, technical readiness level, I would say between 6 and 7, depending on which engine you look at. Because our technology scales up and down so well, we're actually developing multiple at the same time. And for the larger aircraft, I would say in a couple of years, we'll probably start developing those. Something that we're working on right now, which is completely separate from commercial aviation, is a leaf blower. We're basically working to develop a really quiet leaf blower for the outdoor power equipment world. I don't know how much Minnesota uses leaf blowers, but Tennessee has a huge leaf blower use of leaf blower because we have so many, leaf changing trees, and it's actually really exciting to be working with a very big name in the outdoor power equipment space to bring that to life in the next few years. We also got awarded a NASA award to develop ventilation for the space station. So those will be conceptually designed in the next six months by our team. Tristan came in with another question. For smaller general aviation airports to be used for this type of thing, there would need to be significant upgrades to airport infrastructure. Are states looking into funding for airports for these type of upgrades? This is a great question, and I'm definitely very passionate about this as well. Reconnecting looks at this exactly, right? It's like, we don't want the airport to put in this huge amount of money to then maybe not have any new operations for many years. But we do need those infrastructure upgrades to start rolling in today, basically, from the grid and power lines to large electric chargers, to batteries to store that energy in, to even terminal and parking lot upgrades. There's definitely a lot of programs in place from the federal and state level. I'm sure Joseph is way more familiar with what's available in Minnesota. There's, lots of available dollars for airports to apply to upgrade in all these different ways. At Crossville Memorial Airport, our airport, Whisper is actually working to get an aviation electric charger into the airport, so that we can just kind of learn through the experience of what does that look like, and then eventually get those operations working out of the Crossville Airport.
Well, if there are no more questions from the audience, I have one final thing to say, and that's please fill out the survey. We seriously do look at your feedback and constructive criticism when planning future webinars. So let us know what you thought. So with that, thank you for attending. Thank you to Lauda for her expertise. Thank you to Joe Block for his expertise. And with that, thank you and enjoy the rest of your morning, everybody.
Thanks, everyone.